Finding solutions in an interval for a basic equation involving sine or cosine. Here we are getting to solving trigonometric equations, solving equations that contain sines and cosines. The issue with the idea of solving equations involving sine and cosine is because these functions are periodic. That means that there are always going to be more solutions. There are two ways of handling that idea of more solutions. The one we are looking at in this topic is simply giving a range, an interval on which to find our solutions. Typically, that interval will be one complete rotation in radians. So find all solutions for x in the interval from 0 to 2 pi for the equation. And maybe we'll look at, say, 2 times the cosine of x plus the square root of 3 is equal to 0. That seems like a reasonable equation to play around with. Following the rules of algebra, I can subtract root 3 from both sides of the equation and divide both sides of the equation by 2 to get that the cosine of x is the negative of square root of 3 over 2. And you could use a calculator and you could use the inverse cosine to find a specific value, but that's not what we're going for. We're looking for all solutions within this interval, within the unit circle from 0 to 2 pi, complete revolution. So to approach that, I want to take this into pieces. First, I want to consider the reference angle. For the reference angle, I don't worry about whether things are positive or negative. I have that the cosine of the reference angle alpha will be the positive branch, root 3 over 2. That'll give me something to start. Right. I also know all students take calculus. Cosine is positive in the first quadrant and in the fourth quadrant, so those are out because we have a negative here. Cosine is negative in the second quadrant and in the third quadrant. So there is how we will find our solutions. I want that, just copying from the previous slide, the cosine of our reference angle is the square root of 3 over 2. And we want the particular angles in the second and in the third quadrant for which this works. So thinking back, our table of cosine values. Special angles are 0, pi over 6, pi over 4, pi over 3, and pi over 2. And the values are 1, which is root 4 over 2, root 3 over 2, root 2 over 2, 1/2, which is the same thing as root 1 over 2, and 0, which is the square root of 0 over 2. Right. 4, 3, 2, 1, 0. Take the square root, divide by 2. Nice, easy way to remember all of that. So to find root 3 over 2, we are looking right here at pi over 6. So an angle in the second quadrant with a reference angle of pi over 6 would be this angle here, right? Halfway around is pi, and pi is the same thing as 6 pi over 6. So when we subtract 1 pi over 6, 6 minus 1 is 5, and we get that this angle is 5 pi over 6. Right? Then I'm running out of space, but we can do the same thing down here with alpha in the third quadrant. Again, that's the angle we're looking for, which in this case is going to be pi plus pi over 6, which comes out at 7 pi over 6. So the two solutions to this particular equation are 5 pi over 6 and 7 pi over 6. Again, there are more solutions. There are, in fact, infinitely many solutions, but these two solutions are the ones that occur on the interval from 0 to 2 pi, which is where we were told to look.